Not long ago, my relatives and I faced a few blackouts. In the dark, someone suggested the genius plan they saw on YouTube. Just solder an LED to an AI battery. Sounds simple, right? Except it's a terrible idea. The battery will barely discharge and LED will already go dark, and you'll end up tossing a nearly full battery into the trash. I decided to make something smarter. A simple emergency lighting circuit. What does this little board do? It kicks in when the main power is gone. Yep, the opposite of normal. If there's power from USB or 5V supply, the LEDs stay off. The moment power cuts out, LEDs turn on instantly. You can even configure it with jumpers. By default, the LEDs work only during outages. But if you switch the jumper, they'll stay on constantly. You can use individual settings for two groups of 2 and 4 LEDs on this board. The circuit is super simple. Just a lithium-ion cell, a few transistors, resistors and diodes. Board itself cost around $1.50 total, including the charging board. That's way cheaper than building something with a microcontroller. For the battery, I salvaged a cell from an old laptop pack. Its capacity was too low for a laptop, but still plenty for LEDs. And the LEDs themselves recycled from a 12V LED strip. Free is my favorite price. Here you can see full circuit. Let's simulate it and watch how it works. When 5V is present, the LED stays off. Cut the power and LED lights up. First transistor used to invert voltage. Off becomes on and vice versa. Second transistor makes actual LED switching and current stabilization. The source voltage swings between 3.2 volts for a discharged battery and 4.2 volts for fully charged battery. Thanks to current stabilization, the LED current only shifts about 30%, from 17 to 22 mA. Without this, if you just hook the LED directly, or even with a resistor, the current would swing much more, risking damage at higher voltage. In short, the stabilizer keeps your LED safe and happy. Parts overview. Transistors, almost any NPN structure will work. I used SS8050, cheap and common, available in both SMD and through-hole packages. At least you can borrow transistors from old radio or TV set, but don't try turn it on after that. As long as the transistors held LED current, about 80 mA per group here, you're good. Emitter resistor is optional, but helps stabilize current. Without it, the transistor works just in on-off mode. It's okay if your load can run straight from the lithium-ion cell, then you can drop all these parts. But don't even connect raw LEDs directly to a power source, they will fry. I linked PCB and simulation files in the description. Talking about power switch, board fits both push-button latches and slider switches. Charging is via TP4056 module. I replace its resistor within 2 kΩ. It is responsible for adjusting charging current and limit charge current from 1 amp to nearly 500 mA. I don't want to stress the old fella out, so I am giving him an easy pace to charge. It's highly recommended that you used a protected cell or a charge board with protection. This prevents deep discharge if the lights stay on too long. So there you go, a cheap DIY emergency light you can build at home. Simple, practical and way better than wasting AA batteries on a lonely LED.